I'm gonna see if I can find this in last year's. I'm pretty sure I gave it to you. And we'll give it to them, and I will give one to you when we do squares. The big polygons that we do in geometry, especially at the high school geometry. Now, in elementary school, you probably did not do rhombuses. You might have, you know, when the teacher holds up the figure and says, what is this type of thing. You know, you do rectangles and you do triangles and things like that. But in polygons, we did a lot of triangles. And we still got little stuff to do with triangles, but we've spent most of our time with them. We spend a little more than a week on quadrilaterals, and within that quadrilateral family, we do one big split is parallelograms, and this is the cutout I'll give you when we get over to the end of this. Parallelograms, and that's why I say we're doing them separate, but parallelograms is the big category, and I gave you 4 characteristics. Now, there was a 5th one that I did not give you that we may need to go back and put on our list because it's going to affect us on some of these others. Because what happens is that a rhombus, singular rhombus, a rectangle, and a square are all parallelograms. So everything we know about a parallelogram is true for these. Well, a square is a rhombus and is a rectangle. So all of these characteristics, so they all just kind of filter down, and all of these are parallelograms. So that's why we've got to start with their characteristics. So we need to go, I think we ran out of time the other day for me to give you that other one. So I think I will go back and give you that one. So because I think that we'll need that today. So on lesson 36, I don't have a date on that, but it doesn't matter. We talked about what a parallelogram was. We drew the picture, and we talked about the opposite sides were parallel. Opposite sides were congruent, opposite angles were congruent, consecutive angles are supplementary, and then the last one, and we didn't draw them in there, and so I'm just going to actually put it right here, is, I'm just going to squeeze it in. I'm on page 78. Okay, go back to 78, go back to 78, and the diagonals bisect each other. Now, probably the best would be just to use that picture that's right there. Let me let you, diagonals, that should be plural. Diagonals bisect each other. Now, we could draw a parallelogram. The only one you have on this geometry is the little bitty one. I'm just going to show it to you because it is going to come up today. Well, here's the best picture probably right here. The diagonal, this is a diagonal and this is a diagonal. And what it's saying is that they bisect means it cuts it like this one cuts this one into 2 pieces that are the same, and this one, these 2 are the same. Now, they're not the same both ways because you can see there's a long one and a short one. So you have to be careful of that, but that comes from being a parallelogram. Now we're going to add 2 more things from a rectangle, and then we're going to use all of this, we're going to use all of this together in some rectangle problems. We'll do some sides and we'll do some angles. So, back to page 80. Let's take the geometer, and we use it sometimes as our location spot because we'll talk about triangles around it. Your rectangle is right here. It's over there to the right, almost halfway down. Right here. Okay. Everybody see it? Let me put it up in front of you. Here, let me do it this way. Okay, rectangle's right here. Okay, face up, rectangle's right here. Okay, so let's draw this. And we're going to call it, actually, we didn't give it a name last year, but I'm going to go ahead and give it a name. We're going to call it rectangle ABCD. We are going to go ahead and draw the diagonals. And because we didn't do that on the parallelograms the other day, I'll come back and talk about it again to you. I'll emphasize it right here. Bless you. Okay, and I'm going to call that point E, right there. Now, everything we know about a parallelogram is true for a rectangle because it is a parallelogram. Now, that means opposite sides are parallel. These two sides are parallel. These two sides are parallel. Opposite sides are the same. I think that y'all knew that from elementary school. You know, I think you can tell that. We always talk about the width and the length. These two sides are the same length. These two sides are the same length. Well, we're going to talk the angles in just a second, and I think that'll be a characteristic we're going to add, and I think all the things about the angles will make sense. Now the one that I just added says that the diagonals bisect each other. Well, that means that this one cuts this one in two, and this one cuts this one in two. But I'm not going to mark it yet, because here is two more, I think I call them rules. Okay, number one, all angles are, now what do you know about the angles of a rectangle? They are all the same, which is not true in a parallelogram. So we've got a new characteristic, but you can even be more specific. What kind of angles are they?
Right.
Right angles. All angles are right angles. And we usually mark that like this. Now that goes back now to everything we know about parallelograms. Look at them. If they're all 90-degree angles, one of the characteristics of parallelogram is the opposite angles are congruent. Well, it's like Lainey just said, they're all the same because they're all right angles. These two are the same. These two are the same. These two add to 180. Those two add to 180. Those two add to 180. So all the things we know about angles are true for this one too. Now the second one is going to talk about these diagonals. Now look back at your parallelogram. I think it's real obvious if I draw them, and I didn't draw them, but it was on that picture I had a while ago. There will be a long diagonal and a short diagonal. Always in a parallelogram. There's always going to be one longer than the other. But look at them in the rectangle. The diagonals are congruent. So if you know the length of AC, then you know the length of BD. So segment AC is congruent to segment BD. Now, I'm going to even do more than that. It's really weird. You'd think they'd get harder as you go. The easiest of all the parallelograms is the square. And so we do the rectangles. I think the rhombi, you can make them plural. It's rhombus for one. You can say rhombuses, which most people say, or you can say rhombi and for plural. But I don't think you're as familiar with those. I don't think you use those as much. And that one may be a little weird for you. But then when you put it all together as square, everything ends up being so nice and easy. But what I want to show you, if this one cuts this one in two, and this one cuts that one in two, and they're the same length, then what you're going to find is all four of these pieces are the same. Now here's what they like to do to you. They may tell you that AC is 20. Well, then this would be 10, and that would be 10, and that one would be 10, and that one would be 10. And then you're going to find, much easier than the parallelogram, all of these angles, like this angle and that angle, are going to be the same. These four will be the same. These four in the corners will be the same. It's just kind of interesting the way the angles fall into it. Let's try one. We're going to do one with sides, and then we're going to do one with angles, and then we'll do one with variables. So